Boa noite a todos, é um prazer estar com vocês. Hoje é realmente um dia especial, é uma honra e um privilégio ter Walter Longo falar sobre um tópico que eu reputo absurdamente importante. Primeiro, longevidade. Todo mundo quer ficar velho saudável. Ninguém quer ficar velho numa cadeira de roda recebendo nutrição por uma sonda. Então, isso é um ponto interessante que ele vai conversar. Mas além desse ponto, que óbvio já me interessa aos 67 anos bastante, é um outro ponto interessantíssimo, que é uma dieta que ele desenvolveu, chamado FMD, Fasting Mimicking Diet, a dieta que mimetiza o jejum. E ela tem aplicabilidade na oncologia, em combinação com quimioterapia, em combinação com terapia endócrina, em combinação com imunoterapia. E esses pontos ele vai endereçar na aula. O Walter é um PhD, acho que ele foi para a América para ser músico, a musician in the US originally, and became a PhD. Ele é professor da Universidade of Southern California e tem um laboratório todo desenhado nesse sentido, mas interage diretamente com médicos para o desenvolvimento de estudos clínicos, tanto na América, predominantemente na Itália, originalmente ele é italiano, então ele tem bastante facilidade com todos esses grupos. Nós temos até interesse em tentar fazer alguns estudos aqui no Brasil. A gente sabe das dificuldades de fazer estudos clínicos na área de nutrição. Então, senhoras e senhores, vocês vão ter agora o privilégio e a honra de ouvir Walter Longo. Walter, welcome to Brazil.
Okay, thank you, Dr. Buzaid. All right, so I will talk about first about longevity and cancer prevention, and then I'm going to talk about cancer treatment and a lot of the work we've been doing in the last 20 years on cancer treatment. Now, I always start with this, which is showing smoking and obesity as major risk factors for cancer, heart disease, and Alzheimer's. And I was very surprised when I first saw this from a colleague of mine, Matt Camberland, and then he showed the next slide, which is the same smoking and obesity as risk factor compared to 30 years of age, right? So the smoking and obesity, as important as they are, they almost disappear compared to 30 years of age, right? So for the longest time, we've been preaching treat aging, right? Treat aging first, and of course treat everything else also, but focus on aging. And of course, medicine is not focused on aging. Most of medicine focuses on a problem that is already existing, and a lot of the times it may be too late to intervene. Right? So I came up with this word, juventology and youth span, because I thought there was something missing in the word health span. So health span means can you live long, healthy, but I think now people want to go further, and the longevity field is exploding all over the world. And can you live long, young, right? And now you have some soccer players and American football players that go and play at 45 years of age. It was not possible many years ago. And so now there are ways that they're staying young, right? They're not just staying healthy, they're young. And they can play professional soccer at 45 years of age. And then is it possible to actually make people younger, right? And I won't have time to show that, but so we're also working, not maybe making people young, but can you make somebody 3, 4, 5 years younger biologically, right? Can you turn the clock back a little bit? And what is the effect of that on diseases? And so I just showed you what the effect is, right? So if you treat aging, it's going to be a big effect on lots of diseases. And journalists love to talk about, hey, but Madame Clement, she lived to 122, and I get this comment almost every day, right, from journalists. And like, she lived to 122, she smoked until 117. So of course, you're preaching healthy longevity and healthy lifestyle, but look at that, right? So it doesn't matter. Well, of course, don't be fooled by this and all the comments about people that ate a very bad diet and live long, because when I come on, probably like lots of people we follow, for example, little people in Ecuador that have a particular mutation, and that helps them, that are protected, like the mice that have the same mutation, they're protected from diabetes, from cancer, from cognitive decline, but that's just because they have a mutation in the growth hormone receptor, right? And the mice that have a mutation in the growth hormone receptor live 40% longer, and are very protected against lots of diseases, and the people too, right? So most people don't have these mutations. Maybe she had it, but most of us don't have it. And so we have to work hard at it. And so if you think about 100 years of research on aging, I think most scientists will say the most powerful research that started 100 years ago is the one on calorie restriction. So if you take a monkey, a mouse, a rat, almost any organism, and you just cut the calories, don't touch the food, just keep the same food, but just cut the calories by 20, 30, 40%. They live longer, they're healthier, and so, for example, now we're talking about cancer. When the monkeys were taken studied in Wisconsin, University of Wisconsin, and they were calorie restricted. So they just took monkeys, they took a regular diet, and then they decreased a Western diet. So it decreased that by about 25% of the calories. So regular diet or regular diet minus 25% of the calories. And tumors in these monkeys were cut by 50%, right? And this is very much consistent with the work in rats and mice and lots of other organisms, right? But also diabetes and insulin resistance went from 60% to 5%, cardiovascular diseases 20-30% lower. Just not changing food, just changing the amount of it. Now, of course, compared to a normal amount, by coming down 25%. So this was actually Roy Walford. He was my mentor many years ago. And Roy was a medical doctor at UCLA. And when I first joined the lab, Roy was actually inside of Biosphere 2. So the bald man at the bottom left, he was inside of that facility in Arizona, right? And in the Arizona desert, they started the first human trial on calorie restriction. So they were locked inside of this Biosphere 2. And Walford, who was a medical doctor, started making everybody eat less, essentially, right? But he did it in a somewhat of a formal way. It was not a formal clinical trial, but pretty close to it. So everybody now went to this calorie restriction. And if you look at the results, unfortunately, I cannot point, but if you see that the left, on the left is showing the level of blood pressure, glucose, glycemia, fasting, and cholesterol before they enter this calorie restriction study in the Biosphere 2. And then you see they all drop down. So systolic blood pressure goes from 110 to 90, the glycemia goes from 95 to 70, and the cholesterol goes from total cholesterol 185 to 125. So really tremendous effects, right? And so most cardiologists would say this is incredibly impressive. But then if you look at Walford, when he came out of Biosphere 2, and on the left side, right, you see that he's being pushed to the limit and maybe over the limit, right? And so now, since then, I've been thinking, how do you get these incredible effects of calorie restriction without these problems, of course, of lean mass loss, maybe immunosuppression, and lots of other problems that such a severe calorie restriction will cause, right? So one way to do it, and which will be studied for a long time, and many will be studied, is protein restriction. But proteins actually control the same genes that I told you about that are now very well established to be central for the aging process. So growth hormone, GH, insulin-like growth factor 1, IGF-1, TOR, cis kinase, all of these are now very well established by many laboratories to be central for aging and aging acceleration. So protein, and especially animal protein, increase these levels and actually accelerate aging. And I know in Brazil, there is a high consumption of meat, but But that's what the science is showing very consistently, is the animal protein, particularly when the amino acids that are in the animal proteins are increasing the levels of this growth hormone GF1 significantly. So in an epidemiological study, so there's a lot of studies in animals, right? If you reduce protein intake, then animals live longer. The rats live longer, the mice live longer. So what about people? So this was a study using the enhanced, the CDC database, and I'm just going to focus on cancer. So what happened to the people that have a very low protein diet, less than 10% of the calories, versus people that had a high protein diet, more than 20% of the calories, right? And so what happened is that if they were 65 and younger, now the people on a high protein diet had a 400% increased risk for cancer, right? But and this went down a little bit if it was plant-based. It was a high protein, but plant-based, it went down, but it didn't disappear. Now, if they were 65 and older, you see the opposite, right? And so we think this is probably why nobody picked it up, because you have benefits when you're younger and problems when you're older. And so now we're starting to boost in the field the idea of multiple agents, right? So somebody at 20 may have to have a different diet than somebody at 40, at 60, at 80, at 100. So personalization, but we can start with age ranges, right? In deciding, so somebody older might not be able to be as restricted as somebody that is 45. Okay, so now surprisingly, if you look at Okinawa and you look at Japan, historically and still now, although it's going up, there have been a very low protein diet. So Okinawa historically had a 9% protein diet, mostly the great majority of it plant-based. So it was 9% plant-based. And not surprisingly, for a long time, they lived more than anybody else in the world. And Japanese still are #1 in life expectancy in the world, right? And not surprisingly, they have, they're more westernized now, but they still have a high plant-based and relatively low protein. It's higher now, but relatively low protein diet. And not surprisingly, in the old days, in Calabria, in Sardinia, and a lot of places in Italy where you saw little towns having record longevity, lots of centenarians, they had that low protein and high carbohydrate diet, and mostly plant-based, right? So a lot of legumes, and maybe they used to eat meat once a week. That was typical of the Italian, for a long time. It's also true that, let's say, Salvatore Caruso, who made it to 110, he was the oldest man in Europe. It's also true that often when they turned 80s, 90s, they moved in with their sons and daughters, and they had a much higher intake of animal protein. So Caruso probably in the last 20 years of his life, so from 90 to 110, ate a lot of animal protein, right? Because he was now living with sons and daughters. So maybe this is the phenomenon, right? That what I just said earlier, maybe this combination of very poor diet, very restricted, and then all of a sudden they're eating meat 4 times a week, and they're eating chicken 3 times a week, and so this combination clubbed on the trip. Okay, so so then I talk about the longevity diet without going into the details, but the longevity diet is now very much consistent with lots of studies from Harvard, University of Montreal, and I'll show you one from Norway. So mostly plant-based, legumes, whole grains, vegetable, nuts, no red or processed meat, and low eggs, low sugar, low refined grains. This is up to 65, 70 years of age, and then of course what I just said, and things have to change. Still respecting as much as possible this, but without getting into the malnourishment, sarcopenia, muscle loss, and other issues which would be, as I mentioned, for calorie restriction, it could be that the immune system, for example, becomes so weak it cannot fight infections. Okay, so then, so high nourishment, then eat within 12 hours a day, and then these FMDs that I'm going to talk about in a second, fasting intermittent diets. So this is a study in Norway. They looked at lots of people from China, Europe, United States, and basically very much concluded in agreement also with the recent study from Harvard that legumes, whole grains, nuts, very much associated with the largest life expectancy increase, and then red meat with the largest life shortening effect. And so now we're starting to see a consensus for this over and over and over from lots of different sides, and animal studies and human studies. Okay. So, but the reality is people don't want to change their diet, right? So we have the perfect diet, and now you can argue a little bit more this, more that, but pretty much a lot of people are saying, okay, this is probably what people should do, and but nobody wants to do it, right? So Italy now probably less than 10% do the Mediterranean diet, and so in the United States it might be 5%. So nobody's doing this, and Enzo Keys actually defined Mediterranean diet in the 1960s in Italy, and since then Italians have done worse and worse and worse, right? And so they probably decreased the use of the Mediterranean diet as the Mediterranean diet was getting more and more famous as a protective diet, right? So start using it less, not more. So then I started thinking a long time ago, what if we intervene just for a few days, like 5 days, and then let the people eat whatever it is that they eat, right? And so the penguins, for example, the emperor penguins in the South Pole, they go through months of fasting per year. So I was thinking, well, maybe 5 days. What about 5 days or a short period like that? What happens if you do that and then you go back to a normal diet? And so we started working with the fasting mimicking diet. So it's a low calorie, low sugar, low protein, high fat, plant-based diet that has the job of simulating fasting, right? So we trick the human body or the mouse body into responding as if it was just water that they were receiving. And actually we developed this because we ran the first cancer trial. We were running the first cancer trial in 2010, I think it was, at Norris Cancer Center in Los Angeles. And there was a water-only chemotherapy trial. And nobody wanted to do the chemotherapy and water-only fasting at the same time, because people were worried and they felt cheap. And the patient felt, why would you possibly give me water instead of feeding me? I mean, everybody, and even the nurses were like arguing and saying, hey, you should eat something, right, during the trial. So we went back to the National Cancer Institute and asked for funding for the fasting mimicking diet. So the NCI in the US funded it, and so did the NIA, the National Institute on Aging. Okay, so there was if you take mice that are middle-aged, right, and you start giving 2 cycles of the FMD, you give them a normal diet, and then twice a month for 4 days, you give them the FMD. Right? And so the results were really nice and showing about a 45% decrease. I'm just going to focus on cancer because of this talk. So if you look at the overall tumor incidence, it's decreased by about 45%. So even though they got it starting middle age, a lot of the tumors never developed. So they died, many of the mice died without any evidence of tumor. And they lived longer, so they lived about 11% longer on average, almost half of the tumors. And also, if you see all those gray dots are the control mice on the control diet, the regular diet. They're getting a lot of early cancers, right? All the gray dots where it says 20 months, 22 months. You see, none of the mice on the FMD are getting those same cancers, even though they have mostly the same diet, right? Only, say, 8 days a month, they have a different diet. So now a lot of cancers never happens, a lot of tumors never happen, and a lot of the ones that happen later and they are benign, right? So it's really impressive effect, at least in mice, in preventing lymphomas, adenocarcinomas, et cetera, et cetera. Okay, so then what about people? So the first study we published in 2017 is a 100-patient clinical trial in Los Angeles. So this is the human version of the fasting mimicking diet. So lots of nuts and vegetables and soups, etc. So lots of plant-based food that is low in sugar or very low in sugar. So after patients did 3 cycles of this fasting mimicking diet, once a month for 5 days, they the effects were pretty strong. So loss of body weight, loss of abdominal fat, but the lean body mass, unlike what we see with, let's say, GLP-1 receptor agonist drugs, the lean body mass was maintained. So absolute stayed the same, relative went up. Actually, this is now 5 trials after this is still the same, right? Same results. So this is real. It's not just this drug. Okay. So then, what about maybe risk factors or markers for cancer? So high glycemia is associated with high sugar levels, associated with worse prognosis of lots of cancers. And now, differently from the calorie restriction, remember in calorie restriction, you start, if a patient started with low glucose levels, they went further down. Here we don't see that. And that's good and bad, right? So if you have a cancer patient, they start with low glucose and they come down more, that's not good, right? And there is data, in fact, suggesting that people that have very low glucose level, glycemia, they do worse. In some cases better, in some cases worse. But so now, the pre-diabetic, those that start at higher levels of fasting glucose before the 3 cycles of the FMD, they come down, a lot of them, to their normal levels. So this is true for glucose, it's true for IGF-1, and this is a growth factor in epidemiological studies, at least associated with lots of different cancers, colorectal cancer, prostate cancer, breast cancer. So this comes down a little bit if patients had a normal growth factor, but this comes down a lot more if patient had a high IGF-1 at baseline, right? So the cycles are able, and this is true also for inflammation, another potential risk factor for cancer. So C-reactive protein, people that have normal C-reactive protein, they stay there, and people that have higher C-reactive protein, they do 3 cycles of the fasting vegan diet. They're now, you see this being lowered. Okay, so then what about applying it to cancer treatment? And so the idea was, we were showing that if you starve a mouse, the mouse became more resistant to aging and also to toxins, right? So we say, well, this, and we also knew that the oncogenes, I'm going to make a long story short, we knew the oncogenes were blocking this response, right? So if you have an oncogene, which is in all cancers, or the great majority of cancers, the mouse could not respond to the fasting order, right? And they would, so the cells could not respond to the fasting order. And they would continue on being not protected, right? So normal cells get protected, cancer cells don't get protected. And so we first did this a long time, and we and others, with lung cancer model, and I'm just going to show you this for chemotherapy, and then I'll move into the more innovative interventions. So for chemotherapy, the left is lung cancer, and the right is breast cancer, triple negative breast cancer. So if you give mice with lung cancer model chemotherapy, this is just showing the cure rate. This is not showing progression of tumors. Is the mouse cured or not, right? So if it's lung cancer, chemotherapy, no cures. Breast cancer, chemotherapy, 20% of the mice become cancer-free. If you fast them, no cures. If you fast the mice with breast cancer, 20% of the mice become cancer-free. But the impressive thing is the combination, right? So now you fast them, and you give them a fasting vegan diet, and you give them chemo at the same time. Now you're starting to see lots of mice becoming cancer-free, right? And so it's suggesting, it was already suggesting back then, this is like an old study that we did, that the cancer cells did not like fasting, but they could survive fasting, no problem, they can adapt, they could survive fasting. But they couldn't survive fasting plus high-dose chemotherapy. That was a problem, right? And that's why now you see not only the tumor progressing more slowly, but you see them cured. Not all of it, but you know, say a good portion of them now become cancer-free. So then we started seeing some of the pathways that normally go down, particularly TOR. Normally, if you fast a normal cell, TOR signaling goes down, right? This molecule inside the cell that is involved in growth goes down. But we're starting to see that in tumors, in lots of tumors, it was going up instead of down after fasting. And we started thinking about, is it possible that this is the cancer cells are behaving the opposite compared to normal cells? and they're increasing something that normally should be decreasing. And so we started looking at what we call starvation escape pathways, right? Without worrying about the details. But essentially, using RNA-seq, we could look at cancer cells, fast the mouse, then look at cancer cells and look at how they rewire metabolism to survive the starvation condition. Then we can do this very quickly now. We can identify the escape pathways, and then we can target them. And this is what Julia Salvadori did in the lab a few years ago. And she picked up 3 different escape pathways in mTOR, PI3 kinase, and AKT. So she used 3 drugs, rapamycin, pictilisib, and ipatasertib, to target them. And you see that now the cancer goes from going very fast, growing, to coming down, right? So now she's able, by a combination of 3 drugs, first of all, she is able to identify the escape pathways, and then once identified, she targets them. Now, if you remove the fasting mimicking diet, all the mice die of hyperglycemia, right? So now we're starting to see evidence not only of able to kill many more cancer cells and keep it under control, but also protect the mice from hyperglycemia, because the PI3 kinase and the TOR inhibitors, as the oncologists here know very well, they can cause problems, right, by increasing the glucose level. Okay, so then she puts it under control, and I mean, I'm not gonna talk about it, but not only, so on the right is what I just told you, escape pathways, they block PI3 kinase, AKT, TOR, CDK4/6, and on the left, though, is showing another problem about cancer. This is why it's so hard to go after cancer, is the cancer stem cells, right? Now, cancer stem cells don't care about escape pathways. Cancer stem cells, they care about glucose. So now the fasting is on one side, is causing this, together with the drugs, is blocking the escape pathways, but on the other side, is getting rid of cancer stem cells. And that's why this works so well, because of the very wide-acting feature of fasting. Now, if you had to do this with drugs, it would take you 3 plus another maybe 2 or 3 drugs, right? You need 6 drugs to do what the FMD plus 3 drugs can do. And first of all, you will have to know which drugs have differential properties, because now this is creating differential properties. Normal cells go one way, cancer cell goes the other way. So you will need 6 drugs, but you will need 6 drugs with differential properties. They're not hurting normal cells, because otherwise you're never going to solve the problem, right? And this is why this differential idea, sending the 2 types of cells in the opposite direction, is so fundamentally important, because otherwise you're going to do as chemotherapy does, and also immunotherapy to a certain extent, like multiple immunotherapy drugs, to severe damage, severe side effects to the patient. So I think that's very important. Right. So another model was ER positive breast cancer, and so in this case, you see the green, that's cancer growth on the far left. So the green is standard of care, fulvestrant and palbociclib drugs used, right? And so for a while, the mouse is able to control the cancer growth. And then you see the green line eventually goes up, and so the cells became resistant, right? And but now in the bottom curve, you see that it's going down. That's the fulvestrant palbociclib plus the fasting mimicking diet. So now the FMD is acting as a wild card, is making the same cells that normally get resistant come down, and eventually the mice become cancer slowly, one by one, cancer-free. And this is a long study, right? This study is lasting 6 months, so it's a long time for a mouse. Meaning the control was very long-lasting. There was never a resistance opposition. It was just slowly disappearing. Now, I was telling Dr. Buzaid, we try to get this funded for years with some of the top, with MD Anderson, lots of the top hospitals, to do it for patients, and so far we haven't been able to get the trial funded, but we wanted to do exactly the same experiment, but in people. Okay, so then what about non-toxic intervention? Is it possible to take anti-aging drugs like vitamin C and fasting and use it against cancer, right? So the Cantley lab had shown, if you look at the left slide and figure where it says tumor size, this is colorectal cancer, KRAS colorectal cancer in mice, right? And the blue line is mice that are injected with this cancer, and the cancer goes very fast. And then the red is treated with vitamin C, right? Injected vitamin C. So high dose injected vitamin C. The same vitamin C that people take for anti-aging properties. And you see that the vitamin C is able to slow down cancer growth. And then, so Myra in the lab looked at the same, and she used 3 different colorectal cancer, HCT 116 and DLT1 and CT26, and showed, similar to what Cantley had shown as Swan Kettering, that vitamin C, where it says CTR beats C, those are the cells treated with vitamin C, and she sees toxicity. And then lung cancer, she sees a little bit of toxicity, and then pancreatic cancer, she sees a lot of toxicity. But when she adds the fasting conditions, now this changes completely, right? Like I showed you earlier for the chemotherapy plus fasting. Now vitamin C plus fasting, it's got a major synergistic effect. So now this is very interesting because now vitamin C is not toxic to people. In fact, people take it to live longer. Fasting mimicking diet is not toxic. So is it possible that now you can have a very non-toxic cocktail, and this non-toxic cocktail can be used to treat cancer patients? And actually, Anna Baccarin, I don't know if she's here, but she's been using it for a while here in Brazil, and she's been very helpful in giving us all the preliminary data to build clinical trials. And so, for example, now there is a clinical trial on colorectal cancer that just started at USC, looking at immunotherapy plus vitamin C plus fasting in diet, and so we'll see what happens in the trial. Okay, so then you see here the in vivo results. The FMD cycles plus vitamin C are the most effective in slowing down cancer. But now we're combining this with this escape pathways technique that I just showed you about. So now we want to say, can we come up with completely non-toxic cocktail of drugs that can now not cause a slowdown of the cancer, but a regression of the cancer? Okay, so then this is just a summary of that. Basically, the fasting mimicking diet works so well with vitamin C because vitamin C, the cancer cells, as part of their escape pathways, they turn on ferritin, right? So they have a lot of, they have a protein that scavenges iron, right? And iron is what kills by free radical biology, by making oxygen, toxic oxygen. The iron kills the cell. And so the vitamin C turns on the ferritin reduces the iron, and the cancer cell survives, right? But the fasting removes the ferritin, reduces the ferritin, and now it gives the ability to these free radicals, these toxins, oxygen species. It gives them the ability to kill cancer cells. And by the way, killing only cancer cells, because this is happening only in cancer. Normal cells don't care, and they do absolutely nothing. In fact, they may be helping them, become healthier. Okay, so as part of what I just said, now if you look at chemotherapy toxicity, if mice are treated with very high dose chemotherapy, the blue line is if the mice were eating normally, and the red line is if they were fasted for several days before getting the chemo. And you see that in all cases, in some cases, like in the center, this is using a topoisomerase inhibitor, you see that all the mice that are normal diet, and all the mice that are on the fasting mimicking diet or the fasting survive, right? So sometimes you have big differences between the fasted and non-fasted. Another thing that we recently saw, same with immunotherapy. So you see that this is a triple negative breast cancer using 2 immunotherapy drugs, PD-L1 and OX40, and you see that the line that comes down is when the immunotherapy eventually kills these mice, at least in this model, in this 41 model. In all cases, so whether it's PD-L1, OX40, or PD-L1, OX40, and now using the fasting mimicking diet together with immunotherapy, not only is making immunotherapy more effective, which I didn't show you, but it's making the mice less sensitive to immunotherapy, or actually completely protected from immunotherapy. Okay. So then, what about clinical trials? So there's about 20 trials now that are being run out. This is the latest one, the Vernieri group, looking at using the fasting making diet together with lots of different therapies and showing some of the same evidence that we've shown in mice, meaning that, for example, infiltration of the T cells increased in many of the patients, so that the cycles of the fasting making diet are making the cancer more visible to the immune system, right? And so they're making the cancer cells more sensitive to chemotherapy, but also they're making the cells treated with chemotherapy, especially treated with chemotherapy, more visible to the immune system, so the immune system can attack it. And that another trial done in Geneva also looked very promising. And then this is where they showed 5 cases of advanced stage. These are the National Cancer Institute in Milan, Italy, and they're basically showing that in a trial with about 20 advanced stage low prognosis solid neoplasms, 5 of them out of the 20, after receiving whatever therapy, so immunotherapy plus FMD, chemotherapy plus FMD, 5 of them went into remission, right? So this was so surprising to the oncologists that they decided to publish this paper, because getting 5 cases like that in the same trial, going from stage 4 to remission, was not usual, let's say. So they published this exceptional responses. And then the same group now has done overall survival, small trial, right? So we're now doing a 150 people trial, much larger. And but now the bottom is 40 triple negative breast cancer patient survival at 40 months, and you see that if they just receive chemotherapy, the survival is very low, and if they receive fasting making diet plus chemotherapy, the survival is higher. So again, preliminary, but very good start for overall survival. And then they published just a few months. Well, this is by the way, looking at one of the biggest complaints from oncologists, which is the patient is going to lose muscle mass, is going to become cachectic, et cetera, et cetera. And this trial with patients receiving, this is breast cancer patients receiving lots of cycles of the fasting making diet. See, on top where it says phase angle, it basically showing that the women receiving many cycles of the FMD, 8 cycles in this case, they're actually increasing the muscle function and also increasing lean body mass if the FMD was followed by a good diet, enough protein, nourishment, high nourishment diet. So, the big argument we had with the oncologists here was like, well, why would you overfeed him after between cycles? It would have been perfectly fine to keep the muscle mass the same, but try to kill much more cancer cells, but we could not win that argument, and they just decided to overfeed him between cycles, right? And I think it kind of defeated the purpose. But that was, sometimes we lose the arguments with the physicians. Okay, so then, yes, of course, some cancer patients do have a problem. Some cancer patients have to stop doing fasting making diets, but a lot of them don't. And so this is, of course, needs bigger trials. And one of them was just finished and published by the same group, by the Vernieri group, and this is looking at pathological complete response, which is a surrogate for overall survival. And in this case also, they look at chemotherapy plus FMD cycles, or chemotherapy plus FMD cycle plus metformin, expecting that metformin will make things even better. But they saw a big increase in pathological complete response in the FMD plus chemotherapy, like I showed you earlier for the other trial, but metformin didn't add anything to it, right? So it was basically the FMD that did most of the improvements and not the metformin. And this is the last slide I have. Oh no, actually, mechanism right there. So why does it work So it works because the fasting conditions, again, have major differential effects on normal and cancer cells. So if fasting lowers IGF-1, lowers insulin, lowers glucose, and when all these are lowered, the normal cells in a very coordinated way, they know exactly what to do. So in the human body, these are fasting response, and every single cell of the human body in a coordinated way goes into starvation response mode, right? And this is why the penguin of the South Pole can go 2 months. They know exactly what to do, right? Every cell. But the only thing that sticks out are the cancer cells. They're the only one, they're refusing by definition, right? The cancer cells refuse anti-growth order, right? And they have self-growth signals in them, right? These are the hallmarks of cancer. Every cancer cell, or great majority have that. So you know, on one side now you allow chemotherapy, etc., to do much more killing, but probably you're also allowing the immune system to detect that and say and see that this cell is rebelling to the starvation condition. And so you figure that after 3 billion years of evolution, that might be a good signal to the immune system. This is not a normal cell. This is a transformed cell. So go after that, right? Because now it's very clear it's transformed. It's doing the opposite of what it should do. And so this is probably why, you know, it keeps on working with so many cancers. I'll show a few, but now it's been tested for liver cancer, colorectal, and breast, and glioblastoma, and melanoma, so name it, and so by lots of labs. And I think the results are very consistent. Now what we need is bigger trials, more trials, you know, randomized, and so hopefully those continue. And that's it. Thank you.
Well, we received about 1,500 questions, and we're basically kind of clearing them right now. Now, I have a few I'm going to start, as I am the chairman of the meeting, and then I'll go over some very interesting questions that came about. Now, let's summarize first the longevity diet. So the idea is plant-based, small amount of protein, particularly very young, right?
I would say mostly plant-based, but you know, maybe 30% non-plant-based, like fish and other vegetarian foods.
But no red meat. Not very good.
I mean, that's the ideal diet, right? That doesn't mean that most people are not going to do
Let's talk about the ideal first, and then we go over on the barbecue day.
No white meat.
No.
Only fish.
Only fish, very good. Now, talk about supplements. Should we all take omega-3 supplements or not? Or we just go on a diet?
I think it's best to have the omega-3 rich fish, right? Maybe 2 or 3 times a week.
Without mercury, as you pointed out.
Without
mercury-free fish. Yeah. Hard to find now.
Yeah. And also, I mean, if you look at salmon, it contains its own toxins. So, you know, the wild salmon is much lower toxin level compared to the farm raised.
So, if we can't get the good salmon, should we go for omega-3 supplement or not?
Yes.
Yes, good. That's the answer I want to get, because I take every day. So to make sure I'm not being a stupid guy, and I didn't tell him anything. So now, let's review again the behavior of the cancer cell compared to normal cells. So normal cells are designed to stop the metabolism somehow. So you're starving, you're not going to have glucose. So insulin goes down, IGF-1 goes down. The cells start having autophagy, start eating proteins that are irrelevant to survive. Now, cancer cells, because they have driver genes, keep going. They don't respect that starving scenario. And that's why they become more susceptible to chemotherapy, and you pointed out more visible to the immune system. I didn't know that. We may change, my nutritionist is here. So we may change our patients to Mediterranean diet. That's what we normally do. High fiber, Mediterranean diet for immunotherapy, there's a lot of data showing the patients respond better, they cure more if you provide them with Mediterranean diet and a lot of fiber, particularly around 50 grams of fiber per day. This is presented at ASCO 3 months ago. But this is the whole idea, right? So fasting normal cells behave differently. Normal cells and cancer cells behave different under fasting.
Yes.
Tell me about mTOR inhibitors. We use a lot of mTOR inhibitors for treatment of breast cancer and obvious tumors that have receptors, hormone receptors, luminal tumors we call them. And so when normal cells would reduce mTOR activity markedly, right? Even some people wanted to give rapamycin to improve aging or to increase longevity. And normal cells don't do that, so they become more susceptible to the mTOR inhibitors. Is that correct? Did I understand that correctly?
No, normal cells are okay with mTOR inhibitors. Cancer cells, not always, but in a lot of cases, TOR signaling and PI3 kinase and CDK4/6 are elevated.
Right? It's not.
Exactly.
Normal cells under fasting, it goes down.
It goes down, right? Yeah. So, so if you apply fasting and those happen to be escape, not always, because different cancers have different escape. So you can, some cancers we had rapamycin and nothing happens. Some cancers we had rapamycin and a lot happens, right? So it keeps on changing. This is why we use RNA-seq. And hopefully now we're trying to do single cell circulating RNA-seq is hard to do, right? But so that, eventually we can take a blood sample from the patient, look at the cancer cells rewiring, and then within a couple hours we can say, okay, you should get this drug. Right? We can predict, we can identify the escape patterns.
Now the final issue, my final question, then I'll go over the other 1,500 questions, relates to vitamin C. So I think it was around 2015 in Science, there was a paper showing, you show that?
Yeah, show the slide from
it was from colorectal cancer tumors with KRAS mutation. Vitamin C induced death at very high doses, because at very high dose it has an oxidative effect. Low dose is an antioxidant. So it didn't catch very much, but now you showed not just it works, but if you produce fasting in the fasting state, vitamin C high dose works even better. Much better.
Much better, because not surprisingly, the cancer cells defends itself by turning on its own protection, right, against vitamin C. So it turns on ferritin, HO1, hemoxygenase 1, and ferritin, and so ferritin sponges iron and prevents ferroptosis, right? It prevents the iron-dependent killing of cancer cells. But the FMD, the fasting, brings that ferritin back down, and now there is no escape, and this is why it goes out synergistic. It goes up synergistically. When we use vitamin C, we didn't even see that big. I showed that it goes up a little bit. The toxicity by itself is not that big of a deal, but with the FMD, we see it. And even with the FMD, it's not enough to cure the mice, right? Mice. We need to, now we're looking at starvation escape patterns. So vitamin C plus FMD, then we do RNA-seq, we look at the escape, and now we're getting close to running it down like we did for hormone therapy in breast cancer, or triple negative breast cancer.
All right, let me start getting the 1,500 questions here. And that's because some people already cleaned them up. One question that came would be of interest to block IGF-1 in order to prolong longevity.
Well, longevity, no. And this was I think 7 pharmaceutical companies found out the hard way years ago by having drugs that targeted the IGF-1 receptor. And as you may remember, they failed miserably. And nobody knows why they failed, right? But probably because IGF-1 is essential. And so, potentially they were decreasing immune function, because now you're blocking IGF-1 in cancer cells, but this is why I was saying differential effect. You're also blocking IGF-1 in T cells, right? You're blocking IGF-1 in monocytes, in macrophages, in dendritic cells. And so the patient in those trials, several of them were doing worse, right? So they stopped it prematurely. Yeah, so the answer is no. Not IGF-1, but definitely growth hormone, right? I showed you, now we have data from people and from mice and from rats. If you block growth hormone, the mice live lots longer, many less diseases, because now growth hormone does not prevent local IGF-1 production. So you allow the local production of IGF-1 to occur, and that's enough for most cells to get by, including the immune system cells.
But those guys that you studied, they measure what, 1 meter? You know, those 1 meter, most of them is about a meter, right? So they live long, but it's about a meter.
Well, because they're born with it.
I know.
So nobody says
understand.
that.
I understand.
So theoretically, you can intervene later, right? So in people with drugs, right? Let's say you can have a drug, or you can have a dietary intervention. So grow to a normal size, and then intervene, right? Then, yeah, so that's what hasn't been done.
Okay. One of the questions that was asked is how FMD affects the microbiome.
Yeah, so we did publish studies in inflammatory bowel disease, right? And then we showed that the microbiome, the effect of the FMD to the microbiome was very important to protecting the mice against
Inflammation.
Inflammatory bowel disease. And so in people, it's been a little bit harder because when we looked in the clinical trials, if we give patients enough time to go back to their normal diet, by the time we check, the microbiota is back already to, so it's difficult to see. You probably need a big group of people to detect these differences. But while they're on the fasting, making that is a big change in microbiota.
You mentioned about not eat a lot of eggs. One of the questions here was, what's your opinion about protein from eggs and whether or not vitamin D supplementation increases longevity?
Yeah, so eggs, we talk about 2 or 3 a week. And why is that? Because there was a New England Journal of Medicine.
2 or 3 eggs a week?
A week, yeah.
I'm a dead man, so I'm leaving everything to the foundation and 50% to my children.
Actually, if you think about people that respond, from what I remember, genetically only about a fourth of people are sensitive to cholesterol from food, right? And the other 3/4 are not. This is what I remember. It's been a while since I reviewed it. But anyways, I think it was a meta-analysis in the New England Journal of Medicine, more than 3 eggs a week were starting to be associated with mortality increase. And this is why we go with the.
And if we just the white part of the egg, would that work?
Nobody knows.
All right, I'm going to start doing that and see how that goes. One question here. Tell us about vitamin D and your role, keeping it a bit higher. There's a tendency today that most studies suggest that you should take vitamin D to keep it between 40 and 60. You know, the normal limit is above 20. But many studies suggest that higher levels may be beneficial, even reducing cancer, reducing infections because of modulation of the immune system. Can you comment on that?
Yeah, so there's lots of studies on that. And one new one in people showing actually telomere length increasing after in 2 or 3 years of vitamin D supplementation in 2,000 units per day. So I would say you're absolutely right, because if somebody had normal vitamin D and they check it, and because they're under the sun and they have enough, and then there is no need to supplement. But if somebody's got very low vitamin D, then because now we're departing from what we used to do both with food and with the sun, and so some people are never exposed to the sun, and so they may have vitamin D 15, and that probably eventually is going to get somebody in trouble.
There was one question that was placed here was regarding risk of athletes that have a high consumption of calories and protein, but also they burn them a lot. And how do you put exercise into the equation of longevity? I think that's really what this ends up going to.
Well, exercise is important, but I just got this slide from the Buzaid group. It's a research group in Italy, like a government, para-government, and they were showing that bad food takes away about 8-fold more healthy days than low exercise, 8 times, right? So yeah, so exercise, and that's about what I always guessed, right? That'd be about 1 to 5. I always say 1 to 5, but now this showing from 1 to 8. So yeah, exercise is very important, but it doesn't seem to be anywhere near the food power on diseases.
There's one question that I apologize for whoever answers. It's so complicated, so scientific, to skip it. So you need to ask directly to Walter. So question here. We know the cancer cells, 1920 Otto Warburg described the Warburg effect. So cancer cells, despite having oxygen, despite having everything, it always produces glycolysis and produces lactate. Lactic acid is also reduces the pH of the microenvironment. It's one of the mechanisms of immune evasion. T cells don't work well in a low pH. That may explain why cancer cells usually like to produce lactic acid to survive from the immune system. The question here is FMD and the Warburg effect. Can we change that? Can we switch the cancer cells with FMD, or they keep going with Warburg effect? And that's what separates normal cells from cancer cells.
Yeah, we don't want it to change, right?
Exactly.
We don't want it to change. It is exactly what you want the cancer cells to keep doing Warburg, because it's not sustainable anymore. And then we in fact publish on what we call anti-Warburg. They try to go back to mitochondria, but they can't, because now the cell metabolically is rewired. It can no longer have an efficient use of the mitochondria because it's evolved to be glycolytic. Yeah. So then, we want it to be stuck in the glycolysis mode, and so now you reduce glucose, and so, for example, the cancer stem cells, they just the glucose, it's already killing them, right? Just because they're probably so dependent on that high production of the high flux in glycolysis.
Yeah, just for the lay people, and that's why normally we order PET scans that have this glucose with radiation in it, with radioactive material. So, because cancer cells really pull a lot of glucose inside, more than normal cells. Most cancer cells, not all of them. There are a lot of exceptions. Okay. You just explained that we should eat lower animal protein when we are young. And that may relate to mTOR pathway, bringing cancer on in the future. So my understanding, how early should we start doing this? So teenagers, that's the question.
No, not teenagers. I think that a lower but sufficient, right? So 0.8 grams per kilogram body weight per day, right? Not only low but sufficient amino acid content, which should be about. So if somebody eats legumes all day long, that's not going to be sufficient. If it's plant-based, it should be about 3/4 to 2/3 non-legume, right? There should be whole grains. It should be seeds. Those have higher levels of leucine, higher levels of methionine, etc. Yeah, then we always talk about in children up to age 20, probably best to have a Mediterranean diet. Mediterranean diet is much more, let's say, much safer. We think for old people and for young people, because it's being studied in big trials for 50, 60 years, and lots of people grew up on a Mediterranean diet, and so we don't think it's the best, but we don't know what would beat it, right? So until we know, we have a clear idea what would be even better. So we have a pretty clear idea in the 20 to 70 years of age, right? Because 0.8 grams per kilogram per day is safe. Nobody argues, no medical association in the world will say, oh, this is bad for you, right? And but now there's a lot of evidence that you can live longer using that, protein levels are sufficient, but don't go much past that. And now, unfortunately, there's a lot of podcasts, there's a lot of people that know very little about the biochemistry of the human body, talking about 2 grams and very high dose of proteins, and that's going to do a lot of damage. That's already doing a lot of damage. And I suspect, and this is a nice discussion for the next couple of days, that this colorectal cancer and breast cancer we're starting to see in the 20-year-olds.
True.
It may very well be with this protein craze, right? Because everybody's like, we went to look at this, that Italian children were eating in some age ranges 2 to 3 times more protein than any pediatrician would recommend. And not realizing, and because we asked the pediatrician, my patients were eating, and I said, well, let me explain to you what's happening. They're going to school and they're getting meat. Then they come home and they get meat again. In a school and at home, they're giving adults doses of the meat, right? So now you're getting meat twice a day, or like chicken, whatever, and you get a bigger portion because the moms or the fathers say, oh, poor baby.
Not eating well,
like me, right?
Sure.
It's like the baby is 10 kilograms, right? And or 15 kilograms, they need 15 grams of protein. They don't need 30 or 40 grams of protein. So I think, the data is consistent with that. It's going to bring the cancer earlier and earlier, and this is why now the 30-year-olds, we don't know, right? We don't know. But that's certainly a possible explanation for the 30-year-olds getting colorectal cancer.
One interesting question. If you were to advise someone how old you should first start doing FMD, 20, 30, 40?
Yeah, I would say the 20s, right?
The 20s?
And especially because now a lot of people in the 20s, in the United States,
there aren't too many 20s around here, that's for sure. So
people in the 20s.
I'm in a terminal phase, so I understand that. But in 20, there aren't that many.
People in the 20s started to be overweight and obese.
Very true.
It didn't exist before, and now there's a lot of children, and even children younger than 20, that are now starting to have a problem. So I think that clearly metabolically we need a reset once in a while, right? So the sooner in the 20s, we don't want people 15 starting. Although now we're starting with a 300 patient trial in Italy, in Naples, 14 to 18 years of age. So we'll see, right? And so the idea in the Naples trial is that if we start early with this 5-day FMD, maybe we can educate the brain of a teenager into adopting healthier food, right? Without imposing the healthier food for the rest of the month.
Last 2 questions regarding the sarcopenia. Many people are concerned about sarcopenia, but you show very clearly that people doing 5 days of FMD, they end up actually maintaining good muscle mass. And it's been your experience as well?
Yeah, the experience of 5 clinical trials, right? So now the latest one we did at the University of Rome, Tor Vergata, unfortunately they did not. I begged them to use DEXAs, and they used the impedance.
Exactly.
But they showed, I think, 7 kilograms of lean mass gain. Yeah. I don't believe it. In fact, in the paper we wrote, probably it didn't go down. Right. This is what I'm stating. Right.
Sure.
But it showed. It showed. So, for example, when we used the Mediterranean diet, we showed 5 pounds of lean body mass loss. But when with the FMD, no lean mass loss. This was using DEXAs.
And the last question. There are a lot of people, including Dr. Buzaid, that can't stand in a fasting state for too long without killing anyone. So after 6 hours, I have this hunger of killing someone to get food. What are the GLP-1 receptor agonists? Can they be used in that setting to facilitate a person to undergo FMD, or they should not?
No, I think it's a very good question, and as you know, Anna Baccarin has been doing this in Brazil with liraglutide, and so we love to do that trial, right? In an official trial where we use either the microdosing or the short-acting GLP-1 receptor agonist, and just use it enough, because we see people, diabetics regressing, we see pre-diabetic regressing without lean body mass loss, right? So we're basically saying, start with liraglutide. As soon as the doctor feels you don't need liraglutide anymore, get rid of it and just continue with that, right? But if the patient, like you say, keeps being hungry, then you might have to use it for potentially a long time. Right? So I think there is obviously a place for drugs, but I think now they're being overused on lots of people that just want an easy way out, right?
It's a 5-day thing. So if I recall correctly, 700 calories on the first day.
No, 1,100 calories.
1,100? So it went up. That's good.
No, for cancer is much lower.
So for cancer patients, yeah. For cancer patients, 700 first day, 600 in the other days, right?
Yeah.
That's usually what? At least my nutritionist used to say, like 10 nuts surrounded by lettuce around, and maybe 2 cucumbers or something to decorate the plate. I mean, it's kind of, she showed me one day, I can't do this. I told her,
but
I don't think I can do this.
But I think it's implying that you have to do this all the time, right? So if you had cancer, I mean, if I had cancer, I mean, now I understand because we don't have the demonstration. We don't know, right? I mean, we're starting to have some very good data, but we don't know. But let's say that we could demonstrate, like immunotherapy, that it works, right?
Everybody's going to do it.
Yeah, I mean, you're going to say, oh, I'd rather have a sandwich than this. Your life is on the line. Yeah, so it's just a matter of showing in clinical trial. The compliance is pretty good in clinical trial. We have between 60 and 90%. Vernieri gets 90% compliance, right? Because they have oncologists that know about the diet and they follow the patient directly. Right? But I think, yeah, so it's just a matter of proving it. Now, everybody else is a different story, but then I always talk about exercise. In the 50s, nobody exercised, right? And everybody, the doctors said in the 50s, when this came out, when aerobic, the book Aerobic Exercise came out, the doctors say it will kill you. Right? I mean, I forget the name of the author that he said he would go around. He was a doctor, right? But he would go around and his colleagues said, "You're going to kill people with this exercise," right? And yeah, guess what? Now, 60, 70 years later, 50% of American, 50% European, and probably 50% Brazilians do 150 minutes of exercise a week. That's a lot, right? So now you compare that with, let's say, 3 cycles of FMD per year, right? 15 days in a year. I think it's harder to do 150 minutes a week of exercise than 15 days a year of fasting week in that year. So, but I understand, and that's why having GLP-1 helping people, at least initially,
inhibits hunger and be easier. Very good. Ladies and gentlemen, we have to finish. Walter, thank you so much. It was fantastic.